Okay, so this is our first question. We'll start with the basic one. This is an easy level question. So we have to solve the majority element problem.
I'm Ankit and I'm here to help you with the next coding interview. If you're new here, please do like and subscribe.
Now, what is the majority element problem? We are given an array of size n, and then we have to return one element which is in majority, which means there will be one number which will appear more than half of the times. So that number is majority element, and then we have to return that. Now, so the first thing which comes into our mind is how we can do is, okay, let me create a function and let me call it as majority element, or better, get majority element. I'll pass the nums array here, and so the first thing what we are going to do here is, let me define a count map. Count map as a new map. So what I'm planning to do here is, for every number in my number element, also it is nums. So for every number in my number element, I will put it into the count map, and then will keep on increasing the moment I encounter it. So nums, and if, okay, even before this, I have to get the current one. So let, which is my local count of this number equals to count map, and I will get that the number. For the first time it will be 0, so 0. I'll also increment the count here itself. If my count is greater than nums of the length of nums divided by 2, in this case I will just return the number, and otherwise I will update my count map number with the updated count. So this should work. Now let me try to run this. Get majority element, and then let me copy this. I'll save this, and then I'll try to run here. Okay, count map dot set. Oh, okay, because I have to print it as well. So this is my output, and then I will print my output. So here it is, 2. Now, this is all fine that we are using a hash map and then trying to update the count, but then interview might not be looking for this solution, or like this is also an acceptable solution, but then if you come to companies like Amazon or Google, they must be looking for some other better solution. So there is one more way to do this, which is a little bit better than this, where we won't be using any hash map, because consider a case where the load of your array is too high, and then you'll be defining a hash map, so which will consume, in the worst case, n by 2 elements in that hash map, and then every time you have to go to the hash map and then read the values. So there is another algorithm known as Moore voting algorithm. So we will try to use that. So what does that algorithm say is, we pick one element, take the voting, that whether the next number which is coming in is same or not. If it is same, we increase the count. If it is not same, we decrease the count. And the basic principle is, if a majority number is in an array, then it will, like every other number, you can expect it to be that majority number. So next, what I'm gonna do here is, I'll create another function get majority element Moore voting, and same thing, nums. I will define also it's a function. So here what I will do is, first I will define a count as 0. I will also define a candidate, which I will pick as the first element in the beginning. Then I will run the for loop. So for let number of numbers. Now here what I will do, if my count is 0, my number should become, oh sorry, not number, my candidate should be the number, the current number. So because every time our count goes to 0, we have to change our number. So what I will do now here is, if my candidate is the number, then I will increment the count, otherwise I will decrement the count, and then by the end of this process I will return the candidate, because this candidate will be the majority element. So get majority element Moore voting. I'll save this. Some error. Oh, n is not defined somewhere at line number 33. Oh, okay. This is num. Awesome. So yes, so these are the two ways how you can get the majority element from an array. One is via hash map, which is not wrong, which is also correct. But then the only problem here is we are using some memory, so the space complexity will be more here as compared to the Moore one, because here all we need is just a variable for count and a candidate, while here we need a hash map whose length, the length of that hash map can go up to n by 2 times. And also if we talk about the space complexity, this runs in log n, and also this runs in log n. Sorry, not the space, the time complexity of both of these will be log n. So this is how you can solve the majority element problem in your next interview.